This video is going to be about this router table that I put into the extension wing of my table saw. This is a Ryobi router table. The table saw is a Grizzly G0771Z. I made a separate video reviewing the saw. And in this video, I will talk about why I decided to take this approach. I will talk about how I made the frame, made the fence, and set everything up. I will do some calibration checks, and I will go through a short list of my likes and dislikes. So getting right into it, the table itself is a Ryobi universal router table. Bought it from the Home Depot about a year ago. I bought it and the router that's in it for about $160. I looked on the website, Home Depot's website today. The table's going for about $120. The router that I have for about $70. So $190 if you wanted to get the table and router combo. I had the table itself as it was for about 8 months, and almost immediately I realized there were some things that I just did not like about it. One, it was really at a never at a good work height. You can kind of see here, I don't know the exact dimensions, but I'm about 6 foot, and the table, when I put it on the ground, came up to just below my knee, maybe my shin, and that just wasn't a comfortable work height. I was always hunched over, passing things over the table. I decided to try and throw it on my workbench, and that was too high. It came up to my chest, almost my chin. So I never had a good work height with it. It also wasn't very sturdy. It would shake and kind of scoot sometimes when I would pass work pieces over it. But the biggest thing is space. So this is a overview of the space I have for my shop. It's a 2-car garage, and it's used as a 2-car garage when the weather is bad to park both vehicles. So everything that I have here either folds up against the wall or pushes back against the back wall. This table saw is on a mobile base. So when I work under those constraints, I realized that I started to notice something like this router table taking up space. It sat on the floor. I would trip over it. I would usually just use it as a space to stack a bunch of other shit. And then when I needed to use the table, I had to unstack everything. And it was just a hassle. I made this rolling cart for the router table a few months after I got it. The table was still at a, I don't know, kind of a too tall height for my taste. But even this was too much of a space sacrifice. So I was puzzling over what to do. And when I bought this saw, I said, okay, one of the first big projects I'll tackle is putting in this router table. So how I did it. First things first, you will need to level your table's fence rails. These fence rails, this is the entry-level Grizzly model table saw. So these fence rails are actually aluminum. They're not steel. So with enough load, they will bend. And if you put this table and router in it, they will bend kind of noticeably. So the first thing you ought to do is make sure that this fence rail is level. To do that, you need to put a couple of 2x4s, one under here and one under here, and make sure everything is up to level. The reason you need to do that first is because when you start to attach the side pieces, you're going to level them out. And if this is not sitting level when you do that, then when you bring it up to level with your leg or your stand or whatever, then that's going to make your table probably out of level. So first things first, level up the 2 fence rails with some 2x4s. Take your time, sneak up on the fit, and make sure it's precisely level. So once you've got that, you can work on the frame. So the frame, as I designed it, is nothing fancy. It's just a C-frame made of construction lumber. I'm not going to take it apart, but I do have a little model here. I have one long piece and 2 side pieces attached to the long. For the long piece, it needs to be exactly the distance between the fence rails. So right here and right here. This will be absolutely critical if you do the layout for drilling holes method, which I'll show you in a little bit, because that relies on the distance of the long piece being that exact length. So take your time, cut this to size a little bit long, and then again, sneak up on it, make sure it fits snugly. Once you have that, you can attach the side pieces. I attach these side pieces here with glue and pocket screws. So I think I did 2 on each end. So they both came into the long piece. Once I had that taken care of, the first step was to attach the long piece to the cast iron wing. Fortunately for us, both cast iron wings on this table saw are identical, so I'll come over here and show you what you're dealing with. Both of the wings have 3 holes, and I used all 3 of those holes as my points of contact. Ideally, what you would do is take your frame, you would flush it up against the wing. One way to do that would be actually to take something trusty and straight, like a level, and kind of hang it a little bit over the edge, and then clamp to the top of the level and the bottom of your C-frame so that will sit flush. But make sure it's flush, and then you would come under and just screw in 3 holes, 1, 2, and 3, this direction. The problem is there's not enough space here for a drill, so you can't drill a perfect through hole here. And in retrospect, one of the easiest ways to overcome this is to find a dowel. I don't know exactly what size this hole is in inches, but just for illustration purposes, here's a dowel. It's a little bit too big. You would take a dowel, just a little piece, maybe an inch or 2 is all you need, and you would find the center of that dowel. I haven't. This is just, again, for demonstration purposes, but there are tons of YouTube videos that show how to find the center of a circle. Once you find the center of that dowel, you drive a nail into it. This is just a small nail I had lying around, and you shear off the top to create just some sort of point. Once you have that, you come under, you take your dowel with the point, and you would just push it through that hole until it made an indentation on the wood that's clamped on the other side. You do that to all 3 holes, take the frame off, and that shows you exactly where you need to drill your through holes. I didn't think of that. That's probably the easiest way. You could also, if you had another drill bit, or a drill bit that's this size that you don't mind sacrificing lying around, you could just hack it off, again, make an inch or 2, and do the same thing. Just come under and push that drill bit through the hole to make an indentation. I didn't do either of those things. I decided to try and be cute and measure the hole locations and transfer those locations to my frame. In retrospect, this wasn't a terrible idea. I just didn't go about it the right way. So if you are going to try and measure, here's what I would suggest you do. First, you need something to take very accurate measurements. These are digital calipers. I really like these. I use these a lot. You would take your calipers and you would take a couple of measurements. First, you would measure from the outside of the cast iron table to where the hole begins. Just right about there. So right where the hole starts, and you would write down that measurement. These are just some rough measurements I took. Do not rely on these. You need to take your own. But from the end of the cast iron table to the start of the hole, I had it at about 61.45 millimeters. I then took the calipers and I measured the diameter of that hole like this, and I got 11.8 millimeters. Divide that in half, you get 5.9 millimeters. And from there, it was just some simple math. So I took 61.45, which got me to right where the hole started. I took 5.9, which is my radius, which gets me right to the middle of that circle. I added them together and I got this figure. All you would do then is set your calipers to that figure and scribe a line horizontally this way. That establishes your vertical orientation. Then all you got to do is repeat the same for the top. You measure from the top of the table down to the start of the hole. My measurement was 17.25. I added 5.9 radius to get to the middle of that circle, and it gave me 23.15. I set my calipers to that measure, and I scribed this horizontal line. Where those two lines intersect, right here, that's where you would punch a hole and drill through. That approach is easy to do for this hole and easy to do for this hole. kind of tricky for this hole because the calipers really can't reach that far. I really don't feel comfortable suggesting to you that you can get away with 2 points of contact. You might be able to, but I just don't know. So if you want to roll the dice and try and just connect it at the two ends, the two end holes, let me know if that works out. But in any event, so you have the holes marked, you drill your through holes, and then you can attach it to the long side with some bolts. You will need to drill a couple of recesses here. This is for either the head of the bolt, if you're going to attach the bolt this way and put the nut on this side, or if you're going to attach the bolt this way with the nut on this side, the nut will sit into that recess that you drilled. So once you have that attached, you can attach the side pieces. Just a quick note, I did not take my time measuring these holes, and you can see there's a bit of a step off here. It's a little bit low, and as we come to the other side, it's a little bit high, and this was actually a lot worse. I had to do a lot of planing, sanding, and trimming this down, so I did not really think through the layout, how to find the holes well as I should have, so learn from my mistake and don't do that. Okay, so once the long piece is in, you attach the two side pieces. So, starting with this side piece, again, this should be level. You would take a level and make sure the side piece is sitting level, and once you have that, you clamp it to your aluminum fence rail here. And once you have that clamped, then you can come, I just picked a spot at random right here, and I drilled one hole all the way through both the fence rail and the frame. I don't recall exactly how big, I think it was just a small pilot hole. And once I had that hole, I took the frame off completely. I found where that hole was, and then I drilled it through the size of the bolt I was going to use, again, making a larger recess on the other end. After I did that, I counterbored, or I drilled out this hole a little bit bigger. If you've ever tried to drill a bigger hole after drilling a smaller hole, you might know what I'm about to say. It can be very tricky and a little bit dangerous. It can kind of kick and the drill bit can get stuck and kind of twist on you. So take your time with this. If you're not really too worried about how this looks, you can kind of, just eat away at it with the drill bit, then take a file and file it out. You just need it big enough for the head of the bolt you're going to use. Inserting the bolt was a little bit tricky. I think I just kind of, actually I'm not entirely sure how I got that in there, but you just need to be a little bit steady and push, and hopefully it'll not wiggle around on you. If you have some sort of magnetic wand or something, that might help. But this end right here does pop off if you need to somehow get in over here. This actually comes pre-drilled, this hole right here, I believe for that exact purpose. I just didn't make my fence long enough. So if you want to try and use this, go right ahead. But that is a little bit bigger than I had planned for, because again, I wanted it flush with how big it was here, or how wide the table was. So anyway, that's the one side. The other side, pretty much the same thing. You make sure it's level. You clamp it to your fence rail. Here, though, it gets a little bit trickier. So this side has a T-slot area here. Grizzly sells T-slot bolts, and you can get the exact type of bolt that will fit in here and the thickness of the bolt that will fit right there. I just had some random bolt lying around, and I sanded the head down so it would fit into there, and the bolt diameter itself, the thread diameter, was enough to fit into here. You can see this line I drew. This is pretty close to the middle of this track. I, in retrospect, again, would have just used my calipers and taken a couple of measurements. Measure from the top of the frame to the bottom of the track, then measure the track itself. Once you get that measurement of the track itself, divide it by 2, and then you subtract that divided by 2 measurement from your top to bottom measurement, and that brings you up right to the middle. That's where you would mark your line. Then you would have to take the frame off again and drill your through hole right through that line, and then enlarging it, and again drill a recess for your bolt head or your nut. I rushed through this a little bit. I got a little bit frustrated here and there, so I didn't take my time the way I needed to, but if you have it leveled and if you have some patience, and if, again, key, you set this long piece flush like it should be, this is not that difficult. You will have to take the frame off and put it back on, and take it off and put it back on, but that's not that big of a deal. So once I had those three pieces together, the frame itself was pretty much good to go. Then it became a matter of how am I going to support the table. A couple of different options. I went with the most basic. So I just took whatever wood I had lying around and I glued and nailed it, and then came back with some screws and just made some cleats. So if we come under here, you can see this is just construction lumber here. I think I just had, let's see, some pieces of cedar over here. Same cedar over here. It doesn't really matter what wood you use. You're going to glue it and tack it into the side, and it will hold the load just fine. One quick word though, I got a little bit too cute, and I tried to measure the depth of this cleat, the exact thickness of the table. Do not do that. Measure your cleat and set it just a little bit further down than your table. The reason is, if your table sits a little bit lower than your frame, that can easily be fixed by adding some shims and bringing it up to level. If your table sits too high and you've already glued and tacked and screwed these cleats in, then you have a bit of a problem. I had a bit of a problem. This end sat up way too high, and it was really starting to prevent this fence from even moving over it. It would just catch and snag. So I had to do a lot of planing, a lot of shaving, and it's still not level. So that probably could have been avoided by setting these cleats a little bit lower and just shimming that side up a little bit higher. So I would recommend you do that with your cleats, set them a little bit lower, and just lightly shim up with whatever you have lying around to bring it up to level. The last thing I did was attach this front piece here. Again, nothing fancy, piece of wood. I cut out a recess for the switch. I pocket screwed this end into this end of the frame, and over here I believe I just did just a butt joint. I just kind of screwed it in from this side. Not too critical. And that was pretty much it for the frame. The last thing that I did before I took the 2x4s off was to add this leg. Again, these are aluminum, these fence rails, they will sag, and that will throw everything off, so you really do need some support. I kept mine simple. I just took a wooden block, I screwed it into the frame at 2 points, and then I came and cut this 2x4 to sit exactly into this space with it set level. And I came around here and attached a hinge. And that's it. That's really all that it took. After I did that, I added this little block and just some tape to protect the bottom of the leg. The reason I had this little block is because I have this system, 2 hooks with a bungee cord to hold the leg while I'm moving this thing. So if I need to move it, I will just sort of kick the leg, it'll fly up, I'll hook it onto the bungee, and it will hold the leg upright off the ground, allowing me to move the table saw back and forth. Then when I'm done, I just move it down, kind of kick it into place, and I'm good to go. So before I do some calibration checks, I really need to emphasize 2 things. One, you really got to take your time making this long piece fit just so. And that includes the length of it and drilling for your holes. So whether you do the dowel with a nail, whether you use a sawed off old drill bit or whether you measure, you really got to make sure this fits right. If it doesn't, cut another piece and try again. You also really got to make sure this thing is set level initially with two 2x4s under here, and then also make sure these pieces are set level as well. Okay, so that was how I built the frame. Building the fence. Initially, I should say, I have seen this style of fence on several YouTube videos. The problem is, each one of those videos has this as a not permanently attached fixture, right? So that means if you want to use this, first you have to find a place to store it. And then when you want to use it, you have to dig it out. And then you have to find some clamps. And then you clamp it on 2 spots or so. And that just seemed like too much of a hassle. And I wondered if I could get away with just using light 1/2-inch plywood and attaching it permanently to my table saw fence, because this Grizzly table saw has a feature I really enjoy. They have these T-tracks in the fence. And so I decided to take advantage of them and just attach this fence to my table saw fence permanently. Not really that fancy. You can see there's 2 long pieces here with rabbited cuts for the end, rabbited cuts around the dust collection top piece, and then again at both ends. The way to do this would be to take your 2 pieces, your long pieces, and set them facing each other on the table saw, and then just pass them over together, and kind of pass them over, make a cut, and scoot over, make another cut, and that's how you cut out your rabbets. And then when you fold them apart, they will be perfectly spaced, so you don't have to worry about this not lining up. This was, I believe, just about a 30 minutes project. Once I got the long pieces, I cut these side pieces all exactly the same length. I glued and then drove in some pin nails, some brad nails. After I had all those, I attached this portion right here. I'm trying to remember. Yes, I did use a little bit of glue, and you can see one of the nails kind of sticking up. I nailed in through here. This is to attach a dust collection hose, and this works very well. The problem is I need to refine the shape a bit. The dust hose that I use doesn't really fit. It's a little bit too snug, and I need something that fits in there a little more snug, maybe something more compressible that won't easily fall out when a bunch of suction is added on. But this does work pretty well. I should mention that after I attached these side pieces, I did route out, I'm not sure if you can see if I can come around here. I did route out the edges here just on the router to cut that opening, because again, that's covered with the plywood. So you can do that a couple different ways, jigsaw, router, whatever, but you need to cut out that opening. Once I had the frame mostly done, I decided to try and see if I could use or salvage these sliding fence pieces. So I'm not sure if you can see here, but these are the sliding fence pieces on the front. If you'll notice, these slots for these bolts are smaller than they are here. That's because I had to enlarge both the center slot and this outer slot in order to allow me to slide them in and out long enough to allow for a bigger bit in the future. So that wasn't too difficult. I used a straight router bit to enlarge this center part, and then I used, I think, a 1/2-inch straight bit and enlarge this too. Doesn't look all that great, but doesn't need to. Just needs to be functional. And that allows me to use this sliding feature of the original fence, which is nice. I should mention the bottoms of these. I just glued and tacked these in. I cut them to fit, so nothing fancy there. They don't really hold too much load, so I wasn't worried about an incredibly secure connection. All right. After that was completed, I dug out, I don't know what size these are, just 2 random bolts and washers. I ground the head down so they could fit inside of these T-slots. Again, Grizzly sells bolts that fit in these T-slots, so if you're really particular, you might want to use those. But I just picked 2 points of contact, 1 and 2, and this has held up remarkably well. Hasn't really affected the integrity of the fence much. It's already light enough as it is, so I think you can get away with 2. Again, just a word on measurement. To make sure that this hole right here is laid out where it should be, you measure from the top of the fence to the bottom here of the slot, and then you take the slot, divide it by 2, and that's where I would drill my hole. I actually subtracted off a little bit for this top here. I think that was because I was worried that I would for some reason have jigs or whatever that would come across the top of this fence. So I don't think this is necessary, but you might want to inset it down just a little bit. So that is pretty much in a nutshell the setup. I did have to shim here. You can't really see, but behind here I had to shim a bit on the face here just to achieve everything all calibrated. So some shimming will be required. Okay, so time for calibration checks. And I have to confess something. I actually made this video, a router table review setup video, months ago, 2 months ago. And in that video, I did the calibration checks you're going to see me do. And they were so good in my mind that I took that opportunity to run my mouth and say, how could you ever consider buying a $200, $300, $400, $800 router table that sits into an extension wing when you can achieve pretty much professional results with this setup? I didn't post that video because I really wanted to put this through some more of its paces. And I did that when we created this cabinet here. And making the cabinet, made a few router cuts. We made, let's see, just a rounded, rabbited cut on the face, the drawer fronts to accept the center panel. Those went off without a hitch. These gave us a little bit more of a problem though. So this is just a straight cut. These are the side pieces and the back piece for the drawer bottoms there. And this is a 1/2 inch groove to accept a 1/2 inch piece of plywood. If you take a look, it's not too bad. It's not incredibly precise, but it's good enough until we get to right about here. You can see right there, there's a bit of a step. It kind of goes that away. And on this side as well. Unbeknownst to me, what had happened after I shot my first video and bragged about how well this thing was calibrated, sure enough, this, I believe it was this side right here, kind of snuck back on me, or maybe it was forward. And so these two were not on the same plane. One was a little bit in front or behind the other. And as a result, when you pass it through and you get to the end, it kind of steps down a bit, and that can throw things off. So it wasn't huge, but it was noticeable. It made the drawer bottoms not fit initially and just caused me a little bit more of a headache. So I feel I should just go ahead and be honest about that. The calibration checks you're going to see me do are after round 2 of shimming. So take that for what it's worth. I like to do my calibration checks with the fence close to about where I'm going to use it. I realize that I don't really use the router table on this setup with the fence all the way out here or even here. I usually use it pretty close. If I'm all the way out there, I tend to be taking a router to the workpiece as opposed to workpiece to the router table. So this is these, put it right about here just for clarity's sake. This is about the distance I'm going to be doing all of my calibration checks. So the first one we'll do is to see, actually let me scoot back a bit, to see if the table is 90 degrees to the fence. This is not an incredibly critical measurement, but I just kind of want to see how it is. So I'm going to set this carpenter square to the front here, and let's see. That's not too bad. Yeah, that's not too bad. Again, not super critical, because even if this is off, so say this fence is off a little bit, it's going to run parallel across the bit anyway in either direction. So whether it's this way, this way, this way, this way, this way, it's still going to run parallel to the bit, assuming that these pieces are coplanar. So 90 degrees, which is great. I think that's because this fence here, the table saw fence, is 90 degrees, so that really helps. But the more critical measurements are measuring whether or not these faces are 90 degrees to the table, and measuring whether or not these two faces are on the same plane. So 90 degrees to the table, I'm just going to take a tri-square, and I'm going to start back here. See if I can zoom in. You got nothing there. That looks good. That looks good. Right toward the bit is kind of the critical check. That looks pretty good. Just past the bit. Pretty good. Maybe a little bit of daylight, but not too much. And then pretty good. Pretty good. I think maybe toward the end it might get a little bit, might rock just a bit, but I think really the critical measurement again is right by the router bit itself, and that looked pretty good. And then there comes probably the trickiest one to get aligned, just so. Aligning these two sliding face pieces to each other. So I'm going to take this pretty heavy duty aluminum speed square, and I'm just going to hold it against the front here and just sort of run it along. You can see that it's doesn't really come off much at all toward the end, maybe just a hair, but I don't really even notice that. So that's pretty good. And then on the bottom, I just push it up against the fence. That looks good. Yeah, I don't feel any rocking, so not bad. Again, this was after round 2 of shimming, so take that for what it's worth. I'm okay with all of these calibrations, and that leads me right into the likes and dislikes of this setup. I'm a hobbyist. I make things for my house. I make things for my friends, and this type of setup is cheap, $160, and it really does allow me, with a little bit of tinkering, to get really good results. They're not exactly 100% professional grade, but I really don't know what the difference would be. I'm not sure if the untrained eye could even notice a difference. So I like the fact that I can get incredibly accurate results with not a lot of modification, to be honest with you. I like the fact that it is built into this table saw. Can't emphasize this enough. This space, when you buy the table saw, is spoken for space. This is all empty, and nothing's going in there anyway. So storing it this way really only takes up that much of your shop space that otherwise wouldn't be used. So it is a space saver, and I do enjoy that. It is finally at a good working height, so about just below my waist, comfortable. It is sturdy as hell too. I've passed long sheets of plywood, long 2x4s, heavy hardwood, and because it's hooked up to the saw, which is heavy, the thing doesn't rock, it doesn't scoot, it doesn't move at all. So I do enjoy that. I also realized I enjoy this sort of fringe benefit of being able to use the table saw's ruler here. So here's what I mean. If I set my workpiece to here and I make a route and I measure it and I find out, I need to move it to the left 1/8 of an inch. On the old setup, that would be a bit of a headache because the fence was attached here and here with 2 bolts, knobs rather. And so when you wanted to move it, it would always move one way or the other, and then you had to check if it was at the right distance this way and at the right distance this way. and it was a hassle to get it aligned exactly where you want. With this setup, I can just look where I am. So let's say I'm at 16 and I need to move over just 1/8 of an inch. I can just scoot this over. You can just kind of tap the side. Boom. And you can use these very specific or very precise gradations here to really dial in an exact fit for what you're routing. So that's come in pretty handy. I've used that before, and I really do quite enjoy that. The fence doesn't move because it's attached to the table saw fence, which clamps down hard as a rock, and it just won't shake. So that's solid. The space here on the fence I get to use as storage for these throat plates, which came with the table or the router table, so those can be reused. I actually forgot to do one calibration check, and that allows me to show you this thing that I really recommend you pick up. I'm not a big fan of saying you need to buy this. This will make your life so much easier, but in this case, you really need to buy this. This will make your life so much easier. So this is a T-wrench. I think it's made by Rigid. This router table did not come with any way to adjust the router bit from the top of the table. And that was kind of annoying because what you have to do is reach under here, unlock the router. You could maybe use this dial feature, which I never really found to work all that well. But you had to lift and lower it with one hand from under the table. And you had to look up to see if it was moving and look down and look up and look down. It was just difficult. So I nosed around, and sure enough, some helpful commenter somewhere online said that they being Rigid, makes this T-wrench. You can see it's hex there at the bottom. And this part, this is the part number right here if you want to pause the video and write it down. I got this off Amazon, maybe 12 bucks, but if you Google, you might be able to find other vendors. This T-wrench allows you to adjust the bit from the top of the table. On the router table, in the router table's manual, it will have a diagram of where you need to drill a hole to make over-the-table adjustments based on the router you have. And this Ryobi router told me I needed to drill out right here. If you can see straight down, that hex bolt right there is on the router. So all I do is drop in the wrench, and just like that, my shitty, cheap table has a micro adjust feature at the top. So this works pretty good. It's definitely better than the alternative, but I really enjoy this. I cannot emphasize how many times I've had to try and adjust from the bottom here, and it just did not work out that well. So let me crank this up all the way, lock the router from the bottom, take that tri-square again, and that bit looks pretty good. Looks pretty level, pretty much 90 to the table. So that's nice. And if that's a problem, then you can shim this plate here one way or the other. So I really can't emphasize the likes portion of this enough. This has been really handy. This does not cause my fence to bow one way or the other like I thought because this is so light. The only couple of things that I would mention as dislikes. One, I have eliminated the possibility of using this fence to make some sort of wraparound type of jig, like many jigs on table saws are made. So like a tenon jig or a spline jig, that functionality just does not exist if you bolt these in and speak for this space forever. So just know that. The other thing, and this is self-inflicted, this doesn't roll all that smooth once it hits the table because, again, it's just not sitting very level, but that's my own fault. And for whatever reason, I don't know if it's just my concrete floor or just my setup, maybe it's the mobile base, but even though I set this level, sometimes it just is kind of difficult with one leg here to reestablish that level. And I noticed this end right here was kind of sticking up pretty high. in some orientations. So I decided to just drill straight through the MDF and into the frame to kind of make that sink down and make it stay there. And I decided while I was at it to drill in here. I say that as a dislike because ideally you wouldn't have to do that. If this is going to stay in one spot, then I would recommend you put 2 legs of support right here and right here. Don't mess with a side one there, but I may still do that eventually. But this leg sits against the back wall when the router or the table saw is stored, and it does a good job of holding everything up. So for now, I'll leave it. So I really can't think of anything else to say. If you have any questions or if you want something explained a little bit better and more detailed, just let me know. Oh, the last thing. These are router slots. I just used a router, a handheld router, and I dropped it down to the level of this slot and routed these out. You could do this with a chisel, and it can be a little bit bigger. It doesn't really matter. I also don't use this miter gauge a lot, but kind of nice to know that it's there if I needed to use it. So overall, would endorse, would suggest you do this. It is cheap. It is very handy. You get to use a lot of the features of this saw, and is great if you're just starting out or looking for a much cheaper alternative than a $500, $600, $800 router table. So I think that's all I've got. Again, if I missed anything, let me know. Otherwise, I will talk to you later. Thanks.